In topic 3, we talk about determining if an ordered pair is a solution to a linear equation in two variables. Before we can even talk about the solutions, we kind of need to understand what a linear equation in two variables is going to look like. So let's look at some definitions. So first, a linear equation in two variables is any equation of the form ax plus by is c. You need to know that a, b, and c are just real numbers. So a, b, and c could be fractions, decimals, integers, whole numbers, whatever, okay? The only condition is a and b cannot be zero at the same time. If a and b were both zero, we would just get 0 equals c, which would largely not be true. Okay, so you could have a equals 0, which would kind of make that x term become 0, and then you would just have by equals c. You could have y equals 0, which would make that b term become 0, which would just give you ax equals c, but you can't have a and b both be 0 at the same time, okay? And that format, ax plus by equals c, that is called standard form of a line. Or sometimes I think people call it general, but I always call it standard form. So we will talk about other forms of a line as we progress through this chapter, but just know this is called standard form. Now, solutions. A solution to a linear equation in two variables, x and y, is an ordered pair of real numbers. So our solutions are ordered pairs. And it's not just that you have plain old willy-nilly any ordered pair. You have to have an ordered pair such that when the x and y coordinates are substituted into the equation for x and y, you would get a true statement. Okay, so ultimately what we do is we take the x coordinate of the ordered pair, plug it into the equation. We take the y coordinate of the same ordered pair, plug it into the equation. And if it gives us some kind of true statement, that tells us this has to be a solution. Now, there are some additional pieces of information that are super important about the solutions to these equations in two variables. Number one, there are infinitely many solutions, okay? Essentially, when we're talking about the solutions to a linear equation in two variables, imagine a line, okay? That line is made up of ordered pairs, infinitely many. A line goes on forever, so there are infinitely many ordered pairs that form that line. Each one of those ordered pairs is considered a solution to the linear equation. So we do have infinitely many of them, and there's no way to write out every single ordered pair solution to the equation. So we graph it. We give this like visual solution to the equation, okay? So again, there are infinitely many ordered pair solutions to a linear equation in two variables. The ordered pairs in the solution set are the points on the line of the graph. Each ordered pair solution is said to satisfy the equation. So these three pieces of information here, they're pretty important. Make sure you kind of read and understand what's going on here. So now to get to the example for this topic, we have example 4. It says determine whether each ordered pair is a solution to the following equation. And we have the equation 3x plus 5y equals 15. So like I said, kind of in passing earlier, you take the x coordinate and you plug it in for x, you take the y coordinate and you plug it in for y, and then you just simplify to see if you get a true statement. So our equation here is 3x plus 5y equals 15. We know there are infinitely many solutions to this equation because this forms a line and all the ordered pairs that make up that line are the solution, but let's see if this happens to be one of those solutions. So anywhere I see an x, remember x coordinate comes first, I'm going to put a -5. Anywhere I see a y, I'm going to put a 6. So I'm going to take 3 times -5 plus 5 times 6, and let's see if that equals positive 15. So we've done this before, we're just kind of evaluating. So let's see. 3 times -5 is -15. 5 times 6 is 30. And then -15 plus 30 is positive 15. And since 15 equals 15, we could say that yes, this ordered pair is going to be one of the points that makes up the graph. So if we were to graph this equation right here and then figure out where in the tarnation is -5, 6, it would be one of the points physically on that line. Okay? Let's look at part B. So part B, same directions. We're going to determine if this ordered pair is a solution to 3x plus 5y equals 15. So again, we have 3x plus 5y is 15. The x coordinate is 0. Remember, in your ordered pairs, the first number is the x coordinate. The second number is the y coordinate. So anywhere we see an x, we're going to plug in a 0. Anywhere we see a y, we're going to plug in a 5. And then we just simplify. Remember order of operations. So we got to do the multiplication before the addition. So I want to figure out what 3 times 0 is. It's just 0. I need to figure out what 5 times 5 is. Well, 5 times 5 is 25. And unfortunately, 0 plus 25 is 25, and that does not equal 15. So an equals with a dash through it just means does not equal. So we would have to say no. If I were to graph this line right here, we would have the line, and then we would have some random point floating out there that's not touching the line. That would be the 0.05. That would be one of many points that don't touch the line. Okay, finally, let's look at part C. So same directions. We've got the equation 3x plus 5y is 15. We've got an x coordinate of 10, a y coordinate of -3. So where I see an x, I put a 10. Where I see a y, I put a -3. So I get 3 times 10 plus 5 times -3. We want to see if that equals 15. Well, 3 times 10 is 30. 5 times -3 is -15. So I just write that as -15. And 30 minus 15 really is 15. So we get something that is true. So we could say, yes, this is another one of many, many points on this particular line. So it's really helpful and very important that you understand how to determine if an ordered pair is part of the solution set to a linear equation in two variables.